Hi, and welcome to this short introduction to my numerical setup when solving and estimating numerical dynamic programming models, combining Python and C. So first, a disclaimer, this will not be a tutorial on either programming languages. So there's plenty of videos on both Python and C. What I will do here is talk a little bit about how I integrate C in my Python workflow when solving these types of models. Okay. The code that I'll be using and showing you here is based on my GitHub page where I have a setup here you can download. Okay, so you can download this, go through the installation guide down here, and you should be good to go. This might look differently when you get here, but don't worry too much about that. So this is the code base that I'll be working on now. To illustrate my workflow, I'll show you. So what the text editor I use is Visual Studio Code or VS Code from Microsoft. That's what you see here. I find that super useful. It's very well integrated with GitHub, for example. Then I use my setup right now is that I work in a notebook, a Jupyter notebook, and that's what you see here. This notebook you can write Markdown. So this is the model that we'll be talking about in a second. And you can execute code down here, and we'll get to that. What I'll be doing then, I'll be using the notebook to execute code, and all my Python code would then be written in another Python function here called example. And this example file here includes all of the Python setup. So this file will allocate memory and stuff like that, which I'll get back to in a second. And then I have a bunch of C code up here in this folder, CPP function here, which I'll show you in a second how that's sort of linked here. But that's sort of the overall setup. So I'll use a combination of notebooks, Python code, and C code. Okay. The thing that I will, to illustrate you how my workflow looks like, I've solved and simulated a standard buffer stock model using value function iterations in C. Such that we're on the same page, I include in this notebook here the model formulation. It's not super important here, so I won't go through it, but think of this here as the Bellman equation we're interested in. We have some state variables here, cash on hand and permanent income. We can normalize this model such that we only have one state variable normalized cash on hand, M, here, and we are choosing normalized consumption. Again, it's not super important. What we're going to do now is we're going to use C in order to solve for this optimal consumption function here. Okay, and the numerical solution I write a little bit about here. What I have implemented here, you can change that. Again, that's not super important here. What's nice about this setup though is that it's quite easy for us to use C library. So we're going to use OpenMP to parallelize across all the state variables. I'll show that in a second. And we are going to use NLOps C optimizers to actually solve this problem up here. Okay, there's other smarter methods to do this, but this is for illustrative purposes and it's relatively easy to change if you want to do that. There's some expectations here over income shocks, and we're going to use Gauss Hermite quadrature to evaluate that. And then we're going to use linear interpolation to interpolate this next period value function. All these numerical methods, there's other ways to learn more about those, so I won't talk more about that. So what I'll be showing you now is how do I solve this type of model and simulate it using C relatively easily. The thing that I'll be using here is a package built by my colleague Jeppe Drudal, the EconModel class. So I can highly recommend you to have a look at that. So as I write here, this is the class that sort of makes it super easy for us to write Python code and write C code and link them together without a lot of hassle. Okay. And I'll illustrate that now. So first of all, we load some packages. This is a standard NumPy thing. This is just for plotting. And down here, I'm going to load from my example Python code. That's the file I have here. I'm going to load that. And from that, I'm going to import the model class. So my setup is built on object-oriented programming. So I'm going to build a class and store all the information in that class, also the routines that I'm going to use to solve the model. what this this class here inherits the EconModel class that Jeppe Droberg built. Okay. I'll link to his webpage in the description. When I write it like this, it means that it inherits all of the properties of that model class. For this to work, so the good thing about this is that that model class assumes basically that there will be three structures that we'll be using heavily here. You can add more if you want. The first structure is something called par. So par contains all the parameters, all the information I need to know to construct different grids and stuff like that. So for example, here is the gross interest rate. There's some parameters in the utility function. It also stores how many periods we're going to solve this model for, how many points do we want to use in this Gaussian quadrature here, and so forth. Okay, so that's all stored in this par struct. Okay, what we're then going to do is we're going to allocate memory in Python. So this is really nice because memory allocation and deletion and handling memory dynamically in C can be quite a pain. So what's nice here is that we can allocate all this memory here, and you can see here the two other structures that the EconModel class assumes that you're going to use. So the first one is called SOL for solution. So SOL is going to store everything related to the solution you see down here. It's going to store the value function, and it's also going to store the consumption function here. It has two dimensions, time and the number of grid points in our state space. Then finally, we have the third struct that this package is going to assume that you're going to use, and that's the sim struct, and that's going to store everything related to simulation. So when we simulate, we're going to simulate a bunch of stuff, the normalized consumption, normalized resources, and income process, and so forth. Okay. So the key thing here is that the entire setup is built on these three structures here. And I'm going to store everything in these structures, and then that's what I'm going to pass to my C functions in a second. Okay. That means that I can allocate all my memory here, and then just pass that to C. So this subroutine here just sets up the grids. So these are the points in the grid space where we're going to solve for the optimal consumption function. And then when I want to solve the model, I have this method in my Python class here. But this method is going to call a C++ function, also called solve. Okay. The clever thing is that this C function here, that's written in C. Let me show you that. It's over here. So here there's a lot of stuff going on. Basically, the function you see here, this is the heavy lifting function that's going to loop through time periods and maximize this objective function. I'm going to show you that in a second. But all of that is written in C and then compiled in Python. In Python, so as I said, so now I have set up an instance of this model class here. What I do now is I use the EconModel class to compile my C code, and I'll show you that in a second how I write this. The nice thing is that once you have set up your model class here, and you have set up all your memory allocation in these three structs here, the EconModel class will read through all entries in these three structs, determine is this an array or is it just a scalar? What type of scalar is it? Is it an integer? Is it a double? And so forth. And then tell C exactly what to expect when it sees, let's say, the par struct. So for example, if I open here, so this file here is what tells C what's in this par struct. So you can see in this par struct, it knows that there's a double beta, that's the discount factor. There's some other stuff down here that's not super important right now. The really nice thing is that this file that I'm showing you now is automatically constructed when I compile using the EconModel class. So for example, if I delete this file here, and then I run this code, let's restart and run all. When we get to this point here, it will recompile the code. It will read through all of the memory allocations I've done in this par struct, and then it'll construct this C code for me. That's very nice because it means every time I need to change a small thing in my par struct, and maybe I need to add a new parameter or something like that, everything I need to do is allocate that in here, as I'll show you in a second, and then it's constructed. So now it reconstructed this file here that I just deleted before. This is the first key thing about the EconModel class that I find super helpful. I only need to change very few things in my Python code, and the EconModel class handles all of that and makes sure that C knows what to expect when I write those lines of code in C. In my notebook, what I have down here is now I have solved the model here. It took not too long time for 14 or 15 periods here, and then I show what's the consumption function in the last period, what's the consumption function in the first period. This looks very much as expected, and we can also simulate and plot both consumption and average wealth profiles down here. Okay, so you can see in this notebook here, this is where I develop code, I illustrate model behavior, and so forth. Okay. And in the Python file here is where I allocate all of the memory, write subroutines that I'll use in my Python notebook. But a lot of the heavy lifting is done in my C code down here. So how do I actually then link to C? The key thing is that I'm going to write a C wrapper that I call here the CPP link file. So let me show how that looks like. It's super simple, but this is the file that Python will, or the EconModel class, since I've specified that file here, when I compile my code here, this is the file that it'll try to compile using Visual Studio Code. Oh, sorry, Microsoft Visual Studio. This link file here, there's some few things to note. This solve function here, this is written as straight C code, but in front of this function here, we have this word export. And all files that has this export in front of them will be callable from Python. Okay, so note that in here, when I solve, I have this is the model object, then dot cpp dot, and then the function name. So over here, this is the function name when I want to solve. This is the other function name I got to call if I want to simulate. So that's the function that I'm going to do down here. Okay. The inputs to these C functions are now these structs that I talked about before. When I want to solve the model, I don't need the simulation struct. I just need the solution struct and the parameter struct. So that's what's going to go in here. The key thing, right, is that in Python, I can write all of whatever memory I want to allocate into both par and sol. But since the EconModel class constructs these struct entries on the fly when I compile, C will know what this means. So this is the, if I open the solution struct, right, this is also automatically generated, such that whenever I change anything in my Python code, I don't have to manually change this here. It's done automatically. And C will know what happens in here. Okay. The way that I set this up is that I have a header file where I include different type of packages and stuff like that. So let me show you that. For example, if we're going to use NLOpt, this is here. And here, this is sort of a custom thing that, again, is set up based on the EconModel class. So you shouldn't change this. But what this is going to do is that everywhere where it says export is going to copy in and insert this bit of code here. This is what makes the link possible to Python. Down here, I'm including the par, sol, and sim structs and other kinds of stuff here. Okay, so I have subfiles where I, for example, all of my utility functions or state transitions or stuff like that could be stored in this subfile here with this namespace utils. Right now, I only have the CRA utility. In tools, for example, let me find that. I have different types of functions. I have a lot of interpolators and stuff like that, right? So all of that is sort of in separate files, and then they're loaded into my header file down here. Okay, let me close all this. So this is the link to Python. Okay, so but what I'm doing here now is, because we're solving this model by backwards inductions, I'm loop it backwards, and then for each period, I'm going to solve this optimization problem that I showed you before. So let's go have a look at how does that look like. You can see this solution when I write like this. This is the namespace that's generated in this C function here, right? So this namespace solution, and that's the functions that I'm calling over here. Okay. The one thing to note in C here is that before I can call a function, I have to have it defined first. So it means that the main function will typically, there's ways around this, but the main function will typically be in the bottom. So this is the main function that I call. That's the solve for a given period. In the final period here, they kind of consume everything, not super important. But in periods previous to that, we're going to loop through again all the state variables. So that here is the normalized resources. And we're going to use parallelization using OpenMP. One of the really nice things about this setup is that OpenMP is super easy to implement. So what I'm doing here is I'm just constructing a parallel region with this number of threads. Okay. Everything that's being constructed down here is now private to each thread. And down here, I simply just state that now I want a parallelized for loop, and it's going to parallelize the first loop that it sees after that pragma statement here. So here, that will be the points in this normalized resources state space. Super easy. What I constructed up here is things related to the numerical optimizer. So the NL-opt optimizer here. I won't go too much into detail about how this is set up. You can have a look for yourself, but the important point here is just that this is relatively straightforward to modify and change if you want to, and everything's then parallelized right now. Okay, so have a look at this yourself. Let me illustrate how easy it is for us to change some stuff. So let's say, for example, that I wanted to change the model framework here such that I wanted to introduce a tax or something like that. Let's say a flat tax on income. So let's say I wanted to introduce here that the resources here had some marginal tax rate tau. Okay. How do I do that? Okay, so first of all, the only thing I need to change now is I want to introduce this tau parameter in my parameter struct. So I go here in this place here, and then I say, okay, let's add this tax rate. So Copilot already knows what I want to do. Let's add that here. If I just try to run the code again now without recompiling, it will give me a bug or it will crash, because C right now, if I don't recompile, C doesn't know that this is a new parameter. So in order for me to introduce this in my C code, I need to recompile. One way you can see this is that if I go into my C code now, and I want to add that tax rate here. So I want to add it here. So par, and instead of the dot, it's an arrow here because it's a pointer. It's a little bit for another time. Right now, you can see there's a red curly thingy down here. And this is because I haven't recompiled my code. So my VS Studio knows that this doesn't exist in my par struct. Okay. But what I can do is, once I have recompiled, it will already know that it's there. So what I'm going ahead now and just introducing this tax rate everywhere. So 1 minus that tau on income here. And I also want to add it when I simulate. Okay, so this was in the solution. So let me also add it in the simulation code. So I need to everywhere. I need to add this. I also need to add it down here. like this. Okay, so now I've introduced this. Let's see if I try to recompile. So since I have a true statement down here, it's going to recompile my code and try to solve it again. Okay. Since right now I'm linked to this C file, so if I just run this notebook, it won't be able to recompile it. So I restart here to make sure that it's sort of unbind to this C function. There's other ways of delinking if you want to do that, but this is just what I'm going to do now. And now I'm rerunning the code. What it's doing now here is it's recompiling. Okay, so it takes a little bit of time. If I didn't do any bugs, it's just going to continue, and then it goes down here and it solves the model. So let's see how it went. Yeah, so it was happy enough, no bugs. It resolved the model and simulated down here. Okay, so that was super easy to add a new tax rate and stuff. I didn't have to change anything in my parse struct, so it was done automatically. You can see now here, tau is included in the parse struct. If I open my file over here where I had the red curly thingies before, they're now gone because VS code knows that this is a part of the parse struct. Everything was just smooth. Okay, so I didn't have to think too much about this. The same if I wanted to add a new array or vector or something like that. One thing I just wanted to show, if let's say I made a bug somewhere, how would that look like? So let's say, for example, that I erroneously had a dot here instead of it's already complaining. But let's see what happens. I restart, clear all, and run. Let's see how it handles that when I try to compile up here. It's taking a while. Yep. So it's actually saying that it's being used. So let's restart. That was the thing about the delinking that I told you about before. Let's see if it wanna work now. You can see over here it's constructing a lot of new temporary files. Yes, so now it tried to compile, but it couldn't. Okay, so there's something going on here. And it's actually telling me quite a lot of information. It says that this parse struct is a pointer. Do I want to use this instead? Of course. Let's go change. I still want to restart. Let's clear everything. So now I've changed the problem and see if it want to compile now. Okay, so hopefully you can see that, yeah, so now it's complaining that it's not available for being recompiled. It can happen sometimes in Dropbox, for example. It's a little bit annoying. Dropbox is checking what files you have. That might be the problem here. Anyway, I hope this gave you a quick introduction to how my setup works and how easy it is to link C and Python. The big hurdle is setting it up, and there's an installation guide here, and also have a look at the files that Jeppe, my colleague, constructed around the EconModel class. So there's a lot of resources there as well. I hope this was helpful for you and that you can work with this yourself.